A wonderful little thing. You're charging, right? You're charging. Hi, welcome back. How was parking today? Decent?
No.
It's just as bad as Monday. There you go. That works. That totally works. You charging now? Ish. We're gonna hope it works. Okay, a couple things administrative. Thank you for the quiz. Hopefully it wasn't too challenging. For next week. Okay. For next week, I put up two. Do either, both, or neither. Of course, there's 4 possibilities if you want. I put a primer up, a primer quiz up. Well, all that is really, I mentioned there's not a whole lot of math in this class, and there's not, but there is a little bit. And I put a quiz up essentially that kind of makes you think about that little tiny bit of math. And it's heavy on like percentages, counting, solving for x in a very, very simple linear equation. I mean, real simple stuff. Very little math. Very, very little math. And today's going to be a perfect example of that too. Mostly counting today. Some percentages occasionally. So that quiz is that. This quiz will be answerable after we go over what we go over today. So what we're going to do is, I think anyway, and if I'll move it if I have to. We'll probably end up doing, when I say doing, enough of this idea of the intro to Providence Stack today that you'll be able to nail that quiz for next Wednesday. So I just want to let you know there's 2 quizzes, and that's why. Okay. I try to put as many up as I can, which I know if you're not used to my grading policy, you're like, wait a minute, why are you putting more quizzes? That's more torture. But then you realize that, what?
It's good.
It's good, why?
It's good because some of them are better than others.
Mm-hmm.
And
so, more quizzes.
Your probabilities of
Exactly. Nice. So if you do well on them, they boost your grade, of course. And if you don't think you're doing well on them, what do? You don't turn it in, right? They're optional. So if you bring 2 of them into class and you're like, I did awesome on the rock one, but I totally sucked on the other one, just don't turn them in. Just suck in on. Sucked on in. Yeah, whatever. Don't turn the one that's bad in. There you go. Sorry, try to keep the PG in here. Whoops. Recorded, right? Good. So, make sense? Okay, good. There's that. Also, yesterday I got the camera to behave a little more. I got the okay from my dean to actually buy a new one. So this weekend I will, or tonight if I can. I wasn't able to get one last night. The introduction video from class on Monday that kept cutting out, I think the one from 2:43 yesterday is better. So in case you need to go back and watch the video from the first day of class, their classes is actually, it looks better. It actually recorded better. So when you look at you can look at this from week 1, and their video will be it's uploading right now, but once it's linked and uploaded, you can watch that. Yours is kind of scatterbrained just because it kept cutting off. It was overheating while we were in here, so. Cool? Mm-hmm. Excellent. Just wanted to share that with you so you know what's going on. And I should have launched the PowerPoint too while I was in here. So today, the big point of today is really just to get, and you don't have to write any of this stuff down. You're going to have this PowerPoint loaded for you on the website this afternoon. I have office hours. I'm going to upload it for you guys. I'll have the video posted as soon as I can so I can get it uploaded. Probably not till tomorrow with the video. It's usually about a 1-day turnaround on those because I upload about 17 to 18 gigs of the video, and it takes YouTube a while, plus the network here gets streamed in the middle of the day. So you may have noticed the videos from class Monday showed up yesterday. This will show up tomorrow. But you'll have this PowerPoint this afternoon, so you don't have to write it down. I am going to, we will add stuff to the boards today. You might want to write that down and kind of keep pace with that. But as far as what's on here, you'll have all this available to you. Any notes that I use in class, I'll upload those for you as well. So the deal with today, every stat book I've seen, including this awesome open source one that we're using for this class, every stat book I've ever seen starts exactly the same way. They do this buckshot approach where they hit you with a bazillion terms and a bazillion ideas, and then at some point in that bazillion terms they say things like, okay, so here's a z-score. Remember this when we get to normal distribution. Okay, here's an ogive. Remember this when we get to percentile ranking. Okay, here's a box plot. Remember this when we get to relative position. And you won't, because why would you? That stuff doesn't come for weeks later. So what I've done, and this book is no exception, what I've done is I've distilled down the first part of your textbook and pulled out the information that actually we're going to start using Monday and Wednesday and next Monday and Wednesday, and the other stuff we'll pick up as we need it, if that makes sense. I mean, there's no point in making you learn a z-score formula right now and then saying in week 8, remember, we had that z-score formula? Because you're going to say, no, my brain's filled with OCAM now, and other stuff, like Spanish 2 or whatever you're taking right now. So I tried to distill down today into just the stuff that's actually important for like Monday and later on today, for that matter. Make sense? Hopefully that makes sense. Okay, until I get to rewrite the book myself, which I haven't quite gotten around to yet. So, the big idea of statistics and probability, and today is mostly statistics. This course starts more with statistics than probability, and that'll make more sense when we get about halfway through the course and we make a quantum shift over to probability. They're linked, very much so, but there's definitely a theoretical difference between the two. Statistics is messier, statistics is more human-made. Probability is way neater, it's way more theoretical, and the shaking of the hands of the two sciences is beautiful. It's beautiful. But knowing when to shake hands and when to fist bump and when to just smack them across the face is also important. And I've learned the best way to do that is to kind of start with statistics and bring in prob later. And that's why I bring in the first two projects over the first 6 weeks. Your first two projects are those basic probability ideas creeping in. And then by week 6, we bring them both together in class and you guys are totally ready. So, but for right now, let's focus on data. Let's focus on data. I know you know what this word is. And that definition kind of sucks. Information that is collected. You knew that. You knew that already. But that's what it is. And it takes all kinds of shapes and forms. How many of you guys processed data today when you came here? Everybody raise your hands. Come on now. You all did. Give me some data you processed on the way in here today.
Street names.
Street names. Beautiful, beautiful. Keeping track of your commute? Did you try a different lane?
Actually, I had to swing out of the way and go drop something off at somebody's house I'd never been to.
Information, you're processing your street names. Okay, I gotta take a left on 18th. Or Bend 18/12/Ogden, whatever the hell else it's called. There's that Bend. They changed names 12 times. I don't get that, but whatever, it's Bend. What other kind of data did you process today?
How fast we were going.
How fast you're going, right? How fast you're going. Say that again.
Where to park.
Where to park. Good. Give me names again, too. Is it Sherry Ann?
Shireen.
Shireen. Shireen and
Madeline.
Madeline, thank you. Madeline, Shireen. I want to call you Sherry Ann for whatever reason. Shireen. I got it.
Whenever all answers.
I want to call you Shireen, though. And then we got Madeline. Good. What other data? What other data did you process today?
Oh, how many lanes?
Please tell me your name, too.
Roxy.
Roxy.
How long it took me to walk here?
That's fantastic. How long it took you to walk here? One of the questions when I asked my 105 to process on Monday is, we recently moved, hey Tim, we recently moved our offices up to Grandview Hall, Matt did. And I'm a bike commuter, so when I get here, I used to have to walk from Pioneer down to Mazama, take a shower, or walk back and get my stuff together. We now have a shower in the building in Grandview, which is phenomenal. I want to ask them to estimate how much time I save over the course of a year by having a shower in Grandview. I'm already super stoked. As soon as I found that, I was like a little happy dance. Everyone else in the department's like, whatever, we don't shower here, but you know, the free hippie does. But it's amazing. When you add up all those 5-minute increments or 10-minute increments, how it adds up over a year, you actually sleep in a little bit. Well, 5 minutes anyway. Good. One more piece of data you collected today. Nobody's saying the obvious one, I think. Madeline?
This isn't obvious. I was going to say my son's the nutritional balance of my son's meal.
Not obvious, but so important.
Yeah.
Wicked important, right?
Yeah.
It's not the 4 groups anymore, it's the pyramid now, right? The food pyramid. And
yeah.
then you've got individual, it's not that
It's a
anymore.
plate. Yeah, it
Oh, it's
comes
a
like
plate.
4 different color favorites.
Okay.
You should know that.
I just need a lot of, oh, yeah. My wife filters those for me. She gives me the ones that she thinks I need to see. But the nutrition, as long as I give them carbohydrates, I'm happy. I mean, I know that if you worked on, especially with brain development and all that, but yeah, we'll get that eventually when he's more in kindergarten than he is for 2 weeks in. The temperature. It's damn cold.
Freezing cold.
It's damn cold out today, huh? Welcome to winter. Bend has 2 seasons, winter and August. And we are in winter.
It's supposed to be 70 on Saturday.
70, and it probably will be 70 today. But it was 29 when I got in the pool this morning. Holy crap, I never ran so quickly walking to get in the pool. It's 73 degrees. Hello. You're going, sir.
Just bombed your class.
You did.
4 minutes?
Okay,
What's on the schedule? We can put you on the schedule.
Could you?
Yep.
That's awesome. Thank you, guys. Thank you. Rock on, Kurt. Data. He should have collected data too, actually. It's data for the ASDOCC. Did you guys do that survey in your classes yet so far? We'll come back and get him next week. So anyway, all of this data is wonderful. Some of it was qualitative and some of it is quantitative. I want to make sure we understand those two different words. Qualitative, street names, street names, street names. Definitely qualitative. All that is it's a non-numerical data point. It could be a word, it could be a color, it could be what kind of credit card did you use. That kind of thing, right? What kind of car do you own? All right, those are qualitative attributes. And that's all it is, qualitative or attribute data. So and there's not much we can do with that. We'll see later what we can actually do with that data. Keep track of it, for sure. But as far as crunching and analysis, which is what statistics is kind of all about, There's not a whole lot you can do with that data once you have it. But we'll take a look at what you can do with it later. So that's qualitative. So it was street names is definitely one of them. The nutrition, I'm guessing, is one, unless you're measuring it, which becomes a number. But if you're just keeping track of, like, whether it's a carb or a protein or a fat or a sugar or something like that, that's definitely qualitative as well.
It was a guesstimate. Yeah.
It was a guesstimate. So your estimate, you're estimating a measurement, so that's quantitative, actually. What were the other ones? There was how long it takes us to get here, or how long it took us to walk to class. That's definitely a number there. Roxy, what was yours?
How long it took me to walk.
So those are all quantitative. That's the other kind of data. Is something that involves a number. Something that involves a number. So how long, how far, how much. Say if we're doing the food portions, how much. And I like to break these into two categories. And if you take 244 with us, you'll hear these numbers these words over and over again. Discrete versus continuous. And basically, the only thing that differentiates discrete data from continuous data is how you get it. So if I wanted to know how many people were in this class, how would I discover that information? I would count you. Just go around and count noses. That's pretty much it. All right? So what would that be? By definition, that's called discrete. So how many people in this room? How many stripes on Tim's sweater? How many desks in this room? How many leaves, how many needles on that tree out there? That would suck, but you can count it. How many hairs on my head? Silly data points. How many cars in the parking lot? Not silly. If you're trying to put a case forward for more parking spaces, you might want to know that kind of. How many cars are in the parking lot? How many cars do you have driving around looking for parking? But as soon lots. But then as soon as you apply a different measurement, you say, okay, it's not how many cars are driving around, it's the average length of time you have to drive around until you find a parking space. Then you switch over to this, because you're talking about time, and time isn't counted, time's measured. I mean, I know when we watch the second hand go by, it clicks, click, click, click. But there's time between those clicks that isn't indicated by the second hand. All right, I'm actually glad that clock actually has hands. So many digital things in our world these days. I'm worried about my son being in kindergarten, being able to read a clock like that, so we're working on it at home. But that's a measurement. If I was interested not in how many people were in this room, but what the average height of someone was in this room, number of people in the room, discrete, average height switches down to here. Because in order to know the average height, what do I have to do?
Add them together and divide by the number of people.
Add what together?
Add the heights.
And how do I get those heights? You have to measure. I got to slide I put a tape measure on you somehow and get or ask you. But the only reason you know your height is because you at one point measured it, right? At some point measured it. So you see the difference between the continuous and the discrete. Discrete is generally very easy to deal with because it's very easy to count. Very easy to count things. And by and large, the majority of the Gallup polls that you see in the news, Quinnipiac polls, Rasmussen polls, Gallup polls, are discretely based. When they ask about percentage approval of Americans of Senate, I heard recently, within the past year, that Senate is now less popular than syphilis.
Wow.
The infection rate of syphilis is actually higher than the approval rate of Senate. Well, the reason they do that is they ask a bunch of people, and they count how many said, yes, I approve Senate, over how many they surveyed. That's a count. That's a count. They don't say what's the average weight of your senator, because we don't care about that. Now, sometimes you do care about continuous data. You might care about going back to measurement portions, Madeline, for your child's nutrition. You might have to know how much of a certain drug to give an ADHD child to kind of bring them back. And that's, you do need to know on average that. And that's something that's measured, but it's also something that's very tricky to measure. That's why you need a controlled lab environment to do. Whereas a Gallup poll was done via random telephone calls. More on that in a bit. Does that make sense between the two? Madeline, question?
No, I'm sorry.
No. I'm like an amphibious emotion. Tell me your name.
Renee.
Renee, go ahead.
Can continuous data be relative?
What do you mean? It's a great question.
Something that can move from person to person?
Like, can you think of an example?
Height?
Oh, for sure. It's how you get the data at any given stagnant moment. So yeah, for like my son is 47 inches tall, he was 36, he'll be huge at some point. Absolutely, it'll vary as time goes on. So will discrete data. I mean, I said Congress is now less popular than syphilis. At some point they weren't. At some point, their popularity was above 10%, but it fell to 9%. So yes, it can change, but the idea is at a moment, in a given moment, how do you get it? Do you count it or do you make? Great question. Great question. It can totally. Continuous data tends to move more just by basis of, think about your height. You know, when people ask me how tall, I'm 5'11 and a half, because that's what I remember being told when I was like in sophomore year in high school. But I'm not 5'11 and a half. I'm constantly changing. It's shorter as the day goes on. I'm taller in the morning when I wake up because I was laying down and gravity wasn't working its magic on me. So yeah, constantly moving. The question is how much, and is it measurable? All right. Now I want to break down a real quick overview of 243 and 244 and how they're different. Because there's a reason we have 2 stat courses besides just to torture you. We don't want to torture you guys. We want to make it clear as to why we have you in 2 different courses, but we also want to make sure that you know the difference between them. This is a map showing the electoral votes in the last presidential election, 2012. Okay? Blue states went to Obama, red states went to Romney. Okay, so I got percentages at the bottom, should you care to check out the percentages. Okay? And you can see what happened. It's very, very close popular vote. Very, very close popular vote. 50.6% to 47.8%. Okay, for Obama to Romney. Doesn't quite sum to 100%. Does that bother anybody? That doesn't quite sum to 100%? Okay, does bother you? Okay, no, we're saying, tell me your name again. Yeah.
Oh, but they weren't, Andrea.
Andrea, tell me why it doesn't bother you.
Because there's people who don't vote.
Well, that's true, but this is other people that did vote.
Other people that did vote.
So there's a missing, what is it, like 1.6% or something like that?
Yeah, that's not the only 2 candidates that were
Right.
on the ballot, though.
Contrary to popular belief, we actually do have a multi-candidate system in this country. You would never know it by looking at the news around election time. You think there's 2 parties. There actually are like 6 or 7, depending on any given election, and 1.6% of the population. I think the entire quadrant of Northeast Oregon voted for Ron Paul.
I was just going to say.
Yeah, you drive through Northeast Oregon, and on the sides of barns, 20 by 30 signs, Ron Paul for president. You know, a huge libertarian presence. So yeah, the other 1.4% is made up of libertarians, Green Party, whatever else other parties are out there. Nader's not as much of a presence as it used to be, but he used to run on an independent party. So anyway, hopefully that doesn't bother you too much. Notice the Electoral College does sum to 100% because those votes have to be allotted. So that is 100%. So the popular vote, the Electoral College votes don't get to go to independents very often, if ever. Who knows history and electoral history? Have any electoral votes ever gone to an independent? Is it possible for that to happen? I think it would be in some states, wouldn't it, Sydney?
Oh, well, there was a little thing with Ross Perot.
I was just thinking Ross Perot, because he had a huge, like 20% of the popular vote or something, I think, that year he ran against Mondale?
Yeah.
Reagan?
No.
No, am I thinking the wrong time? Was it
Yeah.
Clinton?
Clinton,
Clinton,
I think
thank
it's
you.
Clinton.
Yeah.
But he got a huge chunk of the popular vote. Did he get any electoral votes? I'll have to look that up.
I think he did get one. It was in a state where their district.
Yes, like a couple of these states, I'm gonna say Nebraska and Iowa, that's probably wrong. A couple of them actually allocated percentage-wise. Most of them are all or none. So, but I think a couple of them actually operate a little bit independently. So anyway, this is descriptive statistics. And the reason why it's descriptive is we collected that data on election day, election night, and a few days after, and then we made a pretty map and we put it together. We collected data and then we report back on it. The only problem with this map is it kind of hides something. Does anybody know what the problem with the description of the votes this way is? Tell me your name again.
John.
John, help me.
Or Jonathan.
Or Jonathan, wherever you want.
The population of the state.
Right. Tell me more.
Well,
That looks very red to me, John.
yeah, but the actual blue states have a higher population rate and more votes inside those electoral votes.
There's a weighted average problem John is totally nailing right now. When I look at this map, it is hugely red. Huge red presence. They're all through the south, through the heartland of the country. You've got some blue on the coast, predominantly in here, but it looks area-wise mostly red, and it is area-wise mostly red. But that's not reflected down here in the popular vote at all. So what some folks have done is they've redistributed the map so that it's weighted by population. So now states with smaller populations shrink down, and states with larger populations blow up. Why is it ridiculous? Why is it ridiculous? But now it looks more evenly matched blue to red, doesn't it?
If I was on mushrooms, it looked cool.
Let's go on mushrooms then. It looks pretty cool to me. But look, find Wyoming.
Only one Great Lake.
Yeah.
Right, there's only one Great Lake. It's Canada ate the other ones. Where's Wyoming? Right here, correct?
Mm-hmm.
Now where's Delaware? This is a geography question for you. I'm gonna go back to the other map. So I'm from Delaware.
Right, tiny.
Right there. That's Delaware, right? Sitting in Maryland, okay? And here's Wyoming. Okay, notice the size difference. But when you go by population, there's Delaware, there's Wyoming. It's phenomenal if you think about it. There's a humongous, as John pointed out, humongous populations on the coasts versus the interior. And it gets even more ridiculous, Tim, for you. There's a look at the counties and how they voted.
Wow.
So this is each state broken up by county. So you can see, compare that to the original.
So the land votes.
Look, California's blue, correct?
Mm-hmm.
California's blue, but look at California there. Predominantly red. But who voted for Obama? LA, San Fran.
Yeah.
The huge population centers. You look along the coast where the populations are. They're the ones that voted for Obama. The interior states that are probably more rural, I guess, by California standards, went conservative, as they often do. But you look at this looks even worse compared to the electoral vote because it doesn't represent it at all. It looks flip-flopped until you weight it by population. That's each county weighted by population. You find LA? Can LA kind of jump out? It's kind of hard to find LA here. But it's not that hard to find it here. That big splotch right there, huh? There's LA County. Where's New York City? I don't know, maybe this huge blue thing right here? With Long Island exploding out here. And then I was thinking, like, oh, I can see the blue now. I think it gets even worse. You can take each county and give it a percentage of red to blue. So the more purple, the more middling it was, if you will. So the more red, the more conservative, the more blue, the more Democratic. And then you can weight it with population again. And poor Tim, I should have had you put your head down for a few moments. But there you go. This is all descriptive though, right? All we did was we took the data that we had and we put it together in some way to be clear. Now, some people are going to look at that and go like, that's completely ridiculous. Totally fine. Some people want to see this. Some people are totally happy looking at that. But all of them simply take data that's been collected and put it out there for our consumption. That's descriptive stat. And that's the majority of what 243 is. However, Madeline, back to your nutrition example. I just can't help but pick on that one. Okay. You're measuring out your amounts or something like that. You're based on what?
It's kind of a ratio.
Okay.
How much protein to how many carbohydrates?
Absolutely.
Just be getting some slow release. I mean, kind of
fantastic, right? Complex versus simple ones, and they get slow release over time. Awesome. Where do the ratios come from?
Me. I don't know.
No, this is fantastic, Madam. Thank you. It's perfect. What I want to get into now, henceforth here, is the other side of statistics, inferential stack. Where the ratios come from is this. This is 244. But I can't help, I know not every one of you is going to 244, so I can't help but slide a little bit of it in here in 243. Because even if I get a little bit over the next 3 or 4 weeks with you, if I slide it in every once in a while, you'll get more than you would get in any other math class, and at least you'll be able to understand maybe the newspaper more, or the ratios more that Matt was talking about. And this has a lot of impact on your life. I'll share a personal story after this. So that ratio came from study or studies that replicated the same results. And they took, these aren't definitions, but I think you'll see what the definitions are via examples. You take a random sample from a population. Okay, so that's not defined. We're defining inferential statistics, and saying it makes predictions. But what it does is it draws a small group from a population. Not necessarily small, it could be a large group from a population. And then it studies something about that group. Or groups. Could be more than one group. Could be a bunch of groups we're comparing. It could be 5 or 6 different groups of youngsters. This gets 70-30, 60-40, 50-50, 20-80, and see which one's more optimal in a certain measurement. But the idea is you're interested in something about a population that's out there, whether it's 6-year-old kids, whether it's 10-year-old kids, whether it's Americans, whatever it is. You want to know about that population, but you can't go ask them all for obvious reasons, right? Give me one obvious reason you can't ask them all. There's too many of them. Now, your population might be very, very small. For example, you guys are a pretty good population. You're my class. And when I talk about you guys, I tend to treat you as my population. I can also compare you to my other 243, 2 different populations. But if I'm interested in the average Oregon community college student, I'd be a fool to use you guys. I have to use, not you guys are fools, or I'm a fool either, but I need to use more of a random selection. What does random mean again? We were talking about it. What does random mean? I haven't defined it here. So what do you remember about yesterday from randomness? A cluster is very, very nice. What does random actually mean? What do you think when you hear the word random? And I know it's worked its way into our conversation, like how random. When you see like a coincidence happens, how random.
No rhyme or reason, just.
I love that. No rhyme or reason. So if I was to pick somebody at random, and I picked Stacy, would that be random? It could be. It could be. Depends on how I chose it, right? If I chose it because I happen to be standing right next to Stacy, that's hardly random.
Right.
But if I chose it because I fed all 35 of your H2O numbers into a machine and pressed enter and Stacy's came out, that's pretty random, isn't it? That's pretty random. And that's the definition of random. If everybody in here has the same chance of being chosen, that's what random means. So if I choose Stacy and I say, okay, I'll choose somebody else at random. What's your name? Jamie. Oh, Jamie. Okay, how do you feel about my randomness now? And then I pick Tiffany. How do you feel about my randomness? Could that have happened if I did it with my little machine in the feed? Yes. But the chance of me selecting only people this close to me starts to look a lot less likely. But if all of you have an equal chance, you would expect a spread with some clusters as we go through the list, right? With some clusters, of course. But that's what random means. Everybody has the same chance of being chosen. Everybody has the same chance of being chosen. Okay? Now, that's abused sometimes by CNN, by Gallup. That is abused. I mean, they use telephone polling sometimes to select survey recipients. Why is that not necessarily the best way to collect data? Not the best way to collect. Shireen, did I say it right?
Yeah.
It's Shireen. Okay,
Because
good.
it's only the people that are watching that show that are going to be.
Oh,
random.
good. You were thinking call it. That's a fantastic idea. If you're volunteering yourself, and that's loaded for a whole host of reasons, not just that. Self-selected. Generally, tell me your name again.
Walter.
Walter, tell me what's on your mind. You're gonna say something.
Only people that have phones would be selected.
Way more general. I was thinking that. On my end, calling people out, not so much Shreen, you're right, calling people in, but you're excluding anybody in the population that doesn't have a phone. Hard as it is to believe anybody wouldn't have a phone, but people don't have phones. And if they have certain blockings on their phone, like if you can't call a cell phone or something like that, that changes it too. Jim, go.
We're also looking at people that might only be available at certain times of the day, like might be more old people that
Yes.
are in the middle of the day. Or
Yes.
need-
And CNN and Gallup and Quinnipiac, they still use telephone calling, and what they've done is they've gotten pretty good at randomizing when they call to kind of minimize that. Anybody who's been called during dinner during election season knows, keep on the line as long as you can. It's kind of fun to talk to them. Then they're bored as hell. They're bored, so I'll check up a conversation with you. Anyway, take a look at this one. Take a look at this one. Take a quick look at that article. You don't have to agree with the claim or even know the study, but kind of look through that really quick. I'm gonna get a little bit more water.
Oh, jeez.
research is.
Ah, jeez.
I love it. This is already good. Good. Very, very good. Very, very good. Very, very good. I sorry about the camera kind of being in the way too. Okay? So, why is it an inferential study versus a descriptive report? Who's being studied here?
307.
A small group. Good. A small group of, looks like 379 adults. So there's our sample. We're going to assume they were done randomly. Very often they're not. Have anybody ever known anyone that's volunteered themselves for a medical study?
Yeah.
I'm an old punk rocker, and my punk friends, I was in college working part-time jobs, washing dishes, they were selling their bodies to science. So very often it's a lot of tattoos in those studies. So 379 people, we'll assume we're done randomly because we have no way of disproving. You can always back check the article if you need to. Go,
But
Madeline.
it says that there's half and half. Like, how do you get a random sampling of a perfect half?
Half
Where
the
half
group-
of them were medium to high consumers, half of the group had a non-existent intake of caffeine.
Say it with me, my friend. Ish.
Ish.
Say it with me.
Yeah,
Ish.
yeah.
Roughly 200 of them, one and 200 of the other. I'm calling 379 400 ish. You have to get cavalier with ishing in here a little bit because you can't take 379 people and cut them in half.
Right.
Or you have to have a person somewhere. So you just have to kind of say, make it 380 and make it 190 and 190 or something along those lines. Ish.
But is that likely?
can't
Like
be
how?
random.
Like getting a perfect half like that? Or
No,
about?
it's how they. You're picking on a very important point. The definition of I can't see what that says. Non-existent intake of caffeine, while the other half for medium to high consumers. What's medium? What's high? Right? Here's the problem. This happens all the time. Relatively recently, I heard about the spike in autism cases. It went from 1 in 150 to 1 in 100. There's now a spike in autism cases. What was hidden under that was they've now reclassified certain disorders as autistic, which automatically inflates the numbers just by the definition. So you have to pick on the definition of what high, what medium, what autism is, what autism isn't. That's I think, the answer to your question, and unfortunately, it's not a good answer. But that's what you have to pick at these things. You have, anytime a qualitative label is put on a study, you have to pick at that label and make sure it's defined well. High intake. Now, I'm sure that high intake is a quantity, 6 cups a day or something ridiculous like that. But how did they settle on 6? How about 1 out of 5? Wouldn't 4 cups a day be a lot of coffee? I'm thinking, it depends on how big the cup is. Is the cup one of these things? God bless whoever's drinking that. Or is it a little A-ounce? You know, I mean, it's all about definitions, right, John? It's all about how you define it. So, Madeline, it's not a very good answer, but it's the best answer I've got for you.
Okay.
And I'm glad you guys are picking the study apart. Thank you for that. I kind of picked it with that in mind. But a bigger picture, you identified the sample of 379 folks. What's the population? Hold that thought. Madeline says that's too small. I say take 244. We'll figure out why it's okay. Okay. And I promise you, it's fine. It's totally fine. It's actually more than you need.
Really?
Assuming it's done randomly. But it's plenty. It's plenty. We'll come back to that 244. I promise you on that one.
Okay.
Who's your population? Why didn't you just ask all of them? And by the way, who's them?
Age.
Say that again.
Age.
More specific, John. Who is the population you're trying to study?
Well, I mean, it could be people that are retired that are drinking coffee at home.
Oh, you're saying who we can draw from.
Yeah.
I'm saying, why was this study even done?
It's done on caffeine and addicts.
It's done on, tell me your name. Luanda, thank you. Caffeine addicts is my population. John, you're telling me who I can go get to bring in for the study. And all of them are part of that population. But Luanda's got it. I'm interested in caffeine addicts and whether or not whatever a jolt is defined as, like another definition, actually happens on a caffeine addict over time. Go ahead, Tim. What's on your mind?
I just said what defines an addict.
What? It's all definitions. What defines a jolt? Right? And this is, I think, when we get down to the high to medium, medium to low, that kind of stuff. I think that's where you get into the Stanford did a study recently, within the past 3 or 4 years, saying multimedia or multitaskers suck at everything. So, like me, if I try to text and walk, the person getting that text is getting crap and I'm going to break my nose and I'm going to trip. And Stanford kind of proved it by showing that when you multitask, you basically do everything pretty poorly. And they broke down multimedia usage by high, medium, and low by certain set quantifiers. And that's where new studies come from. They say, I don't like those classifications. Let's break it down by 4 instead of 3, and then you get opposing studies that might not necessarily even be opposing. It's interesting, but it's all about the definitions you guys are picking at. But I think we can agree on 2 things. The sample drawn was the 379 people, and we're studying caffeine addicts. Everything else is up for argument, up for grabs. When you guys take research methods classes, you'll figure out the best and worst and medium ways to test it. But are we okay with that? Good. And here's why you do it. You are interested in what's called a parameter. A parameter is some measure of a population. So Tim, once I've defined what a jolt is, maybe it's a raise in heart rate. Maybe that's what a jolt is. Maybe it's a 10% increase in heart rate. Maybe it's an increase in blood pressure. Maybe it's an increase in the number of times my eyes blink in a minute. Maybe it's the number of times I stutter over a certain word because I'm so jittery I can't talk right. Once you've defined it, it's got a value attached to it. And the value you want is called the parameter. And that's the measure of the population. You'll never get that, though, because the only way to know the parameter is to know what? The definition, of course, yes, for sure. But you have to know the entire population, don't you? Like, for example, suppose I want to know the average number of times a caffeine addict blinks their eyes in a minute. The only way to get that is to go get every caffeine addict and measure how many times they blink their eyes in a minute and then average them together. You can't do that. There's too many of them. Right? Half of them are in this room. One of them. So, you have to draw the random sample, and the problem with the random sample is its values are called statistics. That's why the course is called statistics, so that's what you actually